Hello, this is Team Ehuspace. We are the designers of Robotic Rover. We are students from the University of the Basque Country, from the Masters of Science and Technologies. And around April, we decided to join the European Rover Challenge. The idea was to apply the knowledge and expertise that we're getting in the Masters together with the background of each of us. The idea was to design and manufacture every single piece and component from the Rover, except for a couple of things that we actually had to buy, like motors and PCB boards. Other than that, we have actually manufactured everything. We have built the whole Rover completely from scratch, designing every subsystem and component. We have had some help from professors from the university and also from Technalia, a local company. It's a research and development company, and they have helped us with some materials and also some guidance regarding things like routing and what kind of PCB board we should be buying. We are 1 month into the actual manufacturing on the Rover, and we are going to show you right now the status of the Rover. It's going to be a challenge to be in Poland, but we are very confident that we are actually going to make it. So let's go and let me introduce you to the team, okay?
Let's go.
So this is where we actually work and live pretty much every day. As you can see, the layout is kind of chaotic, or so to say flexible. And we have the people from structural and mechanical engineering, the people from electronics and control. Piera is the main manufacturer of the Rover. She has pretty much sewn and hammered everything in the actual chassis, and this is where I usually take care of the communications. We can actually start with the mechanical and structure, and I think it's even better if you explain this because you know this better than myself.
Okay, so here's the mechanical platform of the Rover. We have chosen a rocker bogie configuration system. So we have here the rocker leg, who's in charge of climbing the rocks and obstacles that he is going to find during the road. And this one is the bogie and is the main power supply for the advance of the vehicle. We can see here the battery unit. And mainly we have chosen to manufacture the structure with composite elements. This is carbon fiber reinforced plate, and we have some aluminum profiles, and this is a sandwich panel who is doing the legs of this creature. I'm going to show you around the general layout of the Rover after for September, hopefully. So now we are currently working on the integration of the engines and optimizing the space below the Rover on the ground side. And here we have the emergency button, very important.
Si Dani no conecta, no.
Bueno, acción.
Espera, ahora está parado. Dani conecta. Entonces, esta hora debería... Sí, joder. Ahí está.
A ver, parada de emergencia.
Parada de emergencia. Y
¿Otra vez?
En un puto momento, esto arranca.
Parada de emergencia.
Y esto efectivamente para.
¿Funciona?
Funciona de puta madre, tío.
And mainly the layout will have here the batteries and all the modem and communications equipment. We'll have here also the electronic boards and all the electronic components. And on the top of it, we'll put the antennas and the video camera system. So, and on the front, we'll have here the robotic arm. So it will reach in front of the Rover about 30 to 50 centimeters, and it will be capable of performing all the science and soil recovery tasks. And what else? I don't know. So let's have a look now into the robotic arm. And by the way, we have get all those materials, electronic boards and engines, thanks to the support of our professors and also to Technalia, so thank you for all the stuff. Let's go. So here we have Asier, he's in charge of the electronic control side of the robotic arm, and those two are Aritz and Piera, and they are together with me within the structure subsystem, and they are working in the manufacturing and all those cutting things stuff. So, what are you doing, Asier?
Hi, I'm here doing the main block diagram for the Rover's arm. And we have here the control dynamics laws and kinematics and dynamics equations. Here we have the Lagrangian equations results, and here's the angles of our arm in this moment. Here we have an example of the main equations of the arm and a little diagram explaining how it is the arm. And there we have a pair of narrates that they are talking about what is the best structure for the arm.
Let's go now to the telecommunications subsystem.
Okay. Here you have.
Yeah.
What I do here is essentially the communications part and also part of the control system. The whole control is based on an FPGA PCB board. It's a Spartan 6 that actually generates all the telemetry of the different subsystems of the rover, meaning control of the position of the motors, control of the power subsystem, for instance, and we receive the commands from the actual base station, so to say, that it's essentially a laptop connected to a router, and we send the commands to this board that processes them and sends them to the different engines and actuators. The communications are essentially two refurbished regular routers, so the whole communications, including the video, are going to be in a 2.4 gigahertz Wi-Fi connection. What else? And this is actually working right fine at this moment.
That's it?
Yeah, everything works. Pretty much everything electronic is already working. The different subsystems work, the control works, the video works, the communications work. The only thing remaining is to actually put everything on top of the chassis and make some field tests.
Awesome.
Cool. He's in charge of pretty much everything electrical, from the power subsystem to the control board, and also the connection with the engines through the drivers. We have already designed and integrated pretty much every subsystem, and we are in the final steps of mounting everything into the PCB chassis. So what are you doing right now?
So now I'm finishing the layout of the components here, and well, just to finish this and to put them in a PCB. And well, we have thought about instead of putting the transistors, just taking a small IC and just putting a bridge, and well, which is easier.
So please, let's leave our guys working. Have a nice day.
Great.